In the last video, we ended off charging by friction with the combing hair on a dry day example. Now let's get into charging by conduction or contact. If a charged object touches another object of a different charge, the electric charges can actually be transferred between them. We know this, but remember, only the electrons can move. Here are some examples of charging by contact or conduction. Touching a friend, touching a TV screen, or touching a doorknob. On Weebly, I have posted a FET Colorado simulation where you can use John Travolta's leg and arm to conduct a voltage. So there is electricity happening here, static electricity. We've got an insulator and a conductor. So in this case, the electrons are moving from the carpet at which John Travolta's dancing foot is rubbing upon into John Travolta. After that, the buildup of charges, it allows you to play around with John Travolta's hand, and you're able to touch the doorknob, thus transferring that electric charge, or discharging John Travolta's body through a charge. So here's a little explanation of what happens when you are charging by contact in the example of the doorknob. As you walk across a carpeted floor, you may become negatively charged, and this is due to charging by friction. But upon touching that neutrally charged doorknob, you feel a jolt or a shock. But why? So electrons transfer to the doorknob very quickly to become balanced in each object. The jolt or shock is known as an electric discharge, which just means a rapid exchange of charge. Why do electrons want to move to a neutral object? Well, electrons repel each other, and they are going to spread out as much as possible. They will spread out to new objects when available. What happens when a positively charged object touches another object instead of a negatively charged object touching another object? It's the same thing as when a negative charged object touches another object. In this example, we've got a neutral metal sphere which rests upon an insulating platform. When we bring a positively charged aluminum plate towards the metal sphere, the electrons actually come out of the neutral sphere, making the sphere have more of a positive charge. So it's the same thing that happens with positively charged objects. Remember, again, only the electrons are able to move in order to balance charges in both objects. Grounding is another great example of charging by contact or conduction. In grounding, you're removing excess charges, whether they're negative or positive charges that are being removed. So in this example, if the object is negatively charged, upon contact, so upon something touching the other object, the electrons will jump onto the neutral object and then go towards the ground. So imagine right here, you've got a sink, okay? Now this sink is neutrally charged, but the sink has a connection into the ground. So as the object, let's say it's a negatively charged spoon, comes into contact with the sink, the spoon can transfer its negative charges, or its electrons, through the imaginary sink that we have here. And since the sink is neutral, the electrons will go through the neutral object, but then it will become grounded. So all of those excess negative charges are removed. Same thing if the object is positively charged. Upon contact, the electrons, still only moving electrons, the electrons will jump out of the neutral object and into the positive object. So let's say that, again, there's an imaginary sink, like a faucet here. So you've got your faucet, and the electrons are coming through the ground because there's an excess of them, and they moved towards the spoon. So then, thus discharging or taking away the excess charges. For the next video, we're going to be looking at charging by induction.